All right, folks, let's party. I'm Cory Minton, Principal Systems Engineer at EMC. I'm the geek that's been talking about Splunk before it was cool at EMC, and then everybody jumped on the bandwagon with me, which was exciting and tumultuous at times, but now we're in a really cool spot. So what we're going to talk about is evolving with big data and the Internet of Things. Now, I talk kind of loud, and are you guys going to, am I blowing you away or your hair back yet? Okay. The pace may blow your hair off, we'll see. All right, so here's what we're going to talk about. We're going to talk about the fact that big data is, well, it's big. Imagine that. If you took all the data just a few years ago and stuck it on these new, cool, fancy 128 gig iPads, and you stacked it up just a few years ago, you wouldn't even get to the moon. If you take the digital universe, all the data in the world that they expect in 2020, and you put that on those same iPads, you stack it up, it goes to the moon 6.5 times. That's a lot of friggin' data. We're talking about zettabytes, right? Not tera, peta, zetta, right? And they're saying that even a few years after that, we'll be in the brontobyte. Right, we're starting to figure out Latin that I didn't even really know existed. So big data is big, but 90% of the data, so IDC tells us, comes from machines. And that's not too hard to imagine, right? You think about all the connected devices. You folks in IT understand that every device in the data center creates logs, right? Lots of data. How many of you have, let's say, more than 2 connected devices on right now? Okay, so how about 3? Keep your hands up until we say, okay, 4? Anybody have 4 connected devices? Okay, that's all right. So you're creating data, and it's actually machines creating data about you. And the way this data is growing, it's not hard to realize that data growth has to be, like if we're going to actually see data grow this big, machines have to create it because it's not human scale, right? We really can't be doing that. So this data is probably some of the most interesting data in the world. These connected devices, Gartner says there's going to be 26 billion of them by 2020. So actually last year was the first year when there were more connected devices than humans, right? So you can start to see where this comes from. Now, this data being created by machines is also some of the most interesting for the analytic purpose and for deriving business value from it. So connected devices are everywhere. It's going a little too far, let's be honest. You guys seen this? Bluetooth toothbrush? Like, come on, really? Like, we really need to track. Apparently, some of you have such bad hygiene habits that somebody thought they'd solve the problem. I personally don't think it's a big deal. But anyway, so companies that want to derive value from all this data, right, being created by devices both inside the data center, outside the data center, deal with this problem of data silos. Data ends up in a lot of different places, right? You've got your traditional sort of operational IT where you're running transactional systems. You've got this new and emerging sort of data that's being created by maybe new applications you're developing. And then you've got all the data that's being created by all the stuff running those. That's this good stuff for operational intelligence, the data that you need to monitor so that you improve uptime, rapid application delivery, build big data platforms on. So silos, oh, got weird for a second. Silos are bad. Now, granted, there is this technology. Does anybody know what that guy's name is? What? Hadoop, yes, Mr. Hadoop. So Hadoop is this really cool processing framework. You guys probably know where it came from, right out of Google and then Yahoo and all this cool stuff, right? For a long time, or I should say not a long time, last couple of years people have been touting like Hadoop is going to save the world, it's the end-all be-all framework. The reality is that it is cool, and it uses some technologies and some frameworks for processing that have been around for many, many years and packages in a pretty nice ecosystem. The problem is, to derive real value from a Hadoop environment requires you to build stuff. There's a lot of deployment, there's a lot of building and programming that goes in to actually deriving value from a Hadoop infrastructure. Now, the concept of Hadoop is that you can get data from lots of different sources and get it in one place so that you can eventually run queries against it. That's a great idea. But it does require you to build a lot of things, which is fine if you're a development organization. Maybe that's interesting. For most enterprise IT organizations, they want a platform that they can buy and deploy very rapidly to get the value that they were looking to derive. So, what if I told you that there was this really cool platform, these guys that just introduced me, that could bring it all together, right? Take the operational intelligence and the data coming from all these data center systems, take traditional business systems, ingest and index that data, and put it into a framework that can be rapidly deployed, that's lightweight and easy to build, and that can empower the results you're looking to accomplish with big data and the Internet of Things. Here's some fun stories. So this particular platform we're talking about has been used in some interesting ways. Does everybody know what that is? It's Train? I know they're almost out of date. They're not that cool anymore. But there's an organization called New York Air Brake. New York Air Brake is I think they own about 87% of market share for building components that go into trains for control. So as a train goes down the track, it has a big motor in it, it's got brakes, it's got all these different control systems, right? Well, one thing I didn't know that I learned from these guys is a train is like basically a giant slinky, right? So imagine every train between the cars has all this stretchiness, and for a train to move down the track efficiently, it needs to minimize the amount of slinkiness that's going on. So New York Air Brake builds all these components. They started to realize that building connected components, bringing the data from those components was good for a few things. One, it was good for predictive maintenance and monitoring the train and that kind of stuff. But they went even further. What they realized is there was an opportunity to build a business and create revenue by building a software platform that could actually help a train move down the track more efficiently. So they did that using this platform to take all that data from the train and actually build sort of a train autopilot, if you will. Now, that doesn't seem all that sexy, but here's the deal. A train operator like a Norfolk Southern uses more diesel fuel in a year than the US Navy. So a 10% improvement in fuel efficiency on a train has a $1 billion savings. Billion. That's big. They use this platform to build a $1 billion savings for their customers. It's pretty awesome. Cricket Wireless. Everybody's got cell phones. Anybody a Cricket customer here? That's okay, it doesn't surprise me. Hello, Cricket. Cricket operates as a cell provider, and what you may know about cell providers is we like uptime, but like everybody does, right? Uptime, big deal. But they actually get charged if they have tower outages, and because there's contractual SLAs and government policies that say if you have a tower go down, you owe the users credits. So uptime is good. Cricket uses this platform to monitor their systems, to improve their uptime, and they've actually recognized about a $1.2 million a year savings by implementing this platform. Pretty cool. Now, we are in a casino, but as you probably know, online gaming is kind of a big deal these days. So OnGame is actually the company that runs the largest online poker community. Everybody realize that casinos make money when they're open? People are playing, right? If you're down, you're not making money, right? That's kind of a traditional concept. These folks actually recognize $2 million in savings a year based on improved uptimes from the operational intelligence that derived from this platform. Now, ThreatMetrix, our next friend, these folks are the largest digital identity network. Think of them as the analytics company stopping cyber criminals from doing bad things to you. So it's not too dissimilar from think like LifeLock and those sorts of players. They use this platform as the underlying processing framework for all the data that their applications are built on. So they've been actually able to recognize a $1 million cost savings over a year by being able to get applications out faster. Right, to build new applications and get them out to their customers. So it's really cool. So we've been talking about millions of dollars, even billions of dollars of savings. So what's the platform that they use to get there? Splunk is that platform, huh? You guys saw that coming, right? Big surprise. So Splunk, is anybody here, who here is a Splunk customer already today? Okay, a few of you. Who here has like personally played with Splunk? You guys? It's pretty rad, right? Okay, so here's the story. Here's what Splunk does. Splunk is a platform designed to ingest data and index data from lots and lots of different sources. They make it super easy to pull data from your traditional data center sources, so think about servers and logs and that kind of stuff. But they also have these lightweight event forwarders where you can even deploy and embed data collectors on a mobile device and a website. So they make it super easy to get data from lots of different sources into a platform that can universally index that data and then make it available to everybody. So Splunk's goal and their mission corporately is to make machine-generated data accessible, usable, and valuable to everyone. Now, as I said before, 90% of the world's data is machine-generated data, so Splunk is a big deal in the big data space. Now, the reason why people really like it is, one, it's super easy, right? It's really easy to ask questions of the data. For those of you who've played with it, maybe you've heard this before, but people have said it's like the Google of data. Because you set up the ingest and the index, and then when you log in to do your search, it's like Google. You literally can go search Google like you would Google across your data sets. It's very, very powerful. Now, that's neat if you were only talking about it in the log context. That's kind of cool, right? Because we can start to identify outages, stop threats, that kind of stuff in the security and operations perspective. But because this platform is now being used and they've continued to invest in new ways to ingest data, it's actually being used in a lot of new and interesting ways. So actually, organizations using it for business analytics, replacing traditional EDW operations, right? Very cool use case, not only for operations, business analytics, and obviously the Internet of Things. So having the data from millions of sources come to a place where you can ask simple questions kind of sounds interesting. Now, fundamentally, Splunk is different, and the design of any application for big data and the Internet of Things needs to be different. Traditional analytics were done in, against data sets that were traditionally structured, right? That's not a big surprise. Most of our data warehouses were, take data from a few databases, run an ETL process to schematize the data so that we can ask a question of that data eventually. But we kind of need to know the question we want to ask before we write the data to that environment, because it's hard to ask the question in an unstructured way in these traditional environments. That doesn't scale very well. It doesn't model for big data and lots of different disparate types of data sets. So in the new world, what Splunk has done is basically recognize that it's better to actually just universally index the data, create some knowledge objects around the data as it's being written, and then schematize it and organize it once you actually want to search against it. Now, this is fundamentally different. This is not too dissimilar from what they've tried to accomplish in the Hadoop space, right? It's the same concept, right? Land it, and then schema at the point of query, or whenever you write your MapReduce job. That's good, but it's really good for big data. What Splunk has done is simplify it. Now, design does matter. We talked about parallelism, but it also matters in terms of the breadth of your offering. So Splunk has its traditional enterprise offering, which many of you are probably aware of, but they've been expanding the portfolio to include new tools to give you access to other data sources. So some of you said you were Splunk customers. Does anybody have Hadoop up and running in their environment? You do? Okay. So if you have a Hadoop environment that you've got lots of data in, but you're not really good at writing Java queries for MapReduce, and you know Splunk, then you can actually use Hunk, which is a new product from Splunk, to actually use Splunk tools in the queries that you're comfortable with and actually point it at Hadoop data. Very, very cool technology. It actually allows Splunk customers to derive value from existing Hadoop deployments. It also allows you to go the other way and use your existing Hadoop deployment as an archive tier for your Splunk data. So kind of cool, it's a two-way. They're also deploying, and what most organizations like EMC and Cisco and others have recognized is Splunk is a great platform for us to empower customers to monitor our gear. Right? EMC sells a bunch of storage. If you want to monitor and make sure it's up, correlate the data that's going on in your storage platform against what's going on in your network and your server, then we build applications specifically designed to run in Splunk that can pull data from our platforms and make it super easy to interact with that data. And that's built, and what we're finding is a lot of organizations use Splunk as the underlying framework and build applications on top for their particular needs. So it's very, very cool. Now, why is EMC up here talking about Splunk? Kind of seems weird, right? One, it's cool, and I'm a geek. I like to tinker with stuff, and it's really fun. The real reason, though, is that Splunk does traditionally, especially as you scale, it can consume a lot of infrastructure. It's a parallelized application. The concept when I say parallelized application is that it's designed to scale linearly as you continue to add resources. So you can start small with Splunk, you can run it on your laptop. But if you want to grow and ingest more data, you can throw more servers at it, and it continues to scale very linearly. There are customers that literally ingest more than 10 terabytes a day of data using Splunk. Does anybody here have 10 terabytes of new data per day? We'd love to introduce you to Splunk. Okay, anyway, so the idea of parallel architectures, this is what's really important as a design feature, right? Traditional applications were monolithic. They have this point of, as they get too big, they start to fall over. And by the way, so do infrastructure solutions. So storage platforms, traditional storage platforms, dual controller from vendors like EMC and others, have a fallover point, right? At some point, because you have two controllers, you have a bottleneck. So if EMC as a storage company is going to position storage products and infrastructure solutions to a parallel application, it would be disingenuous for us to position non-scale-out platforms. So what you're going to hear us talk about here today is that traditional storage platforms are not designed for applications like Splunk or even applications like Hadoop. You need scale-out. So that's why EMC is talking about Splunk, is because we've built scale-out offerings that can support large-scale and growing Splunk deployments. Now, the way we do that is, first we kind of start it from a storage perspective. There are tiers within Splunk. So young data, recently written data, is the data that's most likely to be used. That's true of you too, right? If we went and looked at any one of your laptops, the data that's within 7 days old, probably what you're going to access. If it's over 30 days old, you're probably not looking at it that much. Does everybody agree with that? Right? So the concept is in Splunk, what they give you the ability to do is tier that data. So that the data that's recently been created in ingest, you can keep it on a very high performance, fast tier. And as the data ages, there's no sense in paying the expensive cost for high performance storage. Why not tier that down to a lower tier? Think of it as an archive process, right? So we build two different storage platforms to support that. Extreme.io is an all-flash appliance from EMC that is phenomenal to use in Splunk. It is scale out. You can add it node by node. It is a clustered scale out architecture. For the cold data, we have Isilon. Isilon is a scale out NAS that's, again, clustered Scaleout product, meaning it's not dual controllers with a bunch of storage behind it. Literally, it looks like a server. It's got CPU, memory, disk in every one, connected by a really fast fabric, and it's a globally coherent resource. So everybody gets access to memory and CPU. It's super cool. So scale out is important because as these things grow, we should be able to just add a box at a time and not have these bottlenecks. That's really good. However, we talked before about Splunk does use a lot of data, right? And if you start to implement some of their high performance, high availability features, it does consume storage because it starts to make copies of that data. So making copies just means I'm consuming more storage. Guess what? Our platforms support a process called deduplication. The deduplication in our storage platforms actually cancels out the overhead associated with implementing the high availability and high performance features of Splunk. That's a big deal. If we can shrink the storage footprint, we save our customers money. That's kind of the end game there, save money, right? And then we also provide services on top of Splunk, to support Splunk that really nobody else has figured out how to do. So not only do we do deduplication, but we also provide things like snapshot services, which are really a complement to the high availability data services that Splunk builds. And then we also do some really interesting things around backups, as well as replication that can, again, complement and augment your Splunk strategy. And those kind of get important really when Splunk becomes critical, right? When you start out in Splunk's a side project you're just using to kind of figure out if it's a tool you like or not, you probably don't need this. But organizations that start to scale and start to ingest north of 400 or 500 gigabytes a day, this gets really interesting. And the reality is many of you may have these platforms in your organization today being used for other applications, more traditional Oracle or SQL databases. You may have Isilon for traditional file systems or video surveillance. It can be complementary. And you can use these platforms, you can use Splunk on these platforms alongside those. So again, scale out, all flash, kind of important, won't beat you over the head with storage. And scale out from NAS perspective, really, really cool. You can put 50 petabytes in a single volume, single file system, single namespace. That's a lot of data. Does anybody here have 50 petabytes? I'd love to send to the EMC storage room to you. No? Okay. All right, so then it's one thing to talk about storage, but we find that most customers don't get as excited about storage as maybe they used to. And what they really want is they want an application, Splunk, to be deployed very, very rapidly. So the way we do that is by building converged infrastructure. Converged infrastructure is the concept of, think of it as data center in a box, right? It combines compute, network, and storage, wraps a virtualization and orchestration layer around it to make it super simple to deploy applications. So what this means is we have an organization called VCE, which was a joint venture between VMware, Cisco, and EMC, that we designed this product called vBlocks, that takes EMC storage, combines it with Cisco networking and Cisco compute, wraps VMware management orchestration and virtualization around it, and we pre-build it in the data center. So it shows up pre-built, pre-configured. Not a lot of organizations today would say, if you talk to their CEO, you wouldn't find them say, our competitive advantage in the marketplace is that we integrate servers and storage better than anybody else, right? That doesn't happen. That's not how people make money. That's not how you drive value. So we've given our organizations the ability to acquire technology in a converged way that speeds the deployment of the application. And again, the application we're talking about here is Splunk. We've actually done the work with Splunk to pre-validate configurations. So if you, let's say you walk into Splunk and you go, hey, I've got a terabyte of data I want to ingest per day. I'd like to keep 30 days in my high performance tier and a year in my low performance tier. We have pre-built configurations that are validated to work for that solution. Already tested in the lab, everybody's happy with it. So that's good, because then it takes, if you want to deploy the application for whatever use case, whether it's operational intelligence, Internet of Things, whatever, we don't want you to have to be slowed down by having to build the infrastructure. Okay? Make sense? All right. So now, what do you do next? If you like what you heard today, if Splunk seems very interesting to you, then Splunk makes it super easy for you to go play with it. If you visit Splunk.com, you can download a free version of this. I highly encourage it. It's really easy to deploy, and it's quite fun. I'll give you some examples. You can Splunk your home internet router. There's apps within Splunk that if you want to monitor your kids and make sure they're not doing anything bad on the network, you can Splunk your router. So you can actually have the logs from your router sent to your laptop, and you can index them and search against them. I'm not saying spy on your kids, but they're your kids. You do what you want to do. Anyways, if you want to deploy in the cloud, you can get a free Splunk cloud license. If you love Amazon, then you can certainly get Amazon instances as well. But they make it super easy to start. And it's really, my personal opinion, that's where it almost always starts in organizations. We've had a number of customers that I've supported that literally the use case for Splunk was they had some network or some outage. Some guy in IT was using Splunk on his laptop. Everybody was freaking out, couldn't solve the problem. The dude literally goes, oh, I found it, and takes the solution to the execs and says, oh, here's what happened. And they go, what's that tool? That's kind of nice looking. Oh, it's Splunk. Do we own that? Are we using that? Oh, no, I just use it on my laptop for some stuff. Really? I'm not kidding. I had a customer that had that exact scenario happen. Within 4 weeks, they acquired a license to do 4 terabytes a day of indexing with Splunk because the execs had no idea what it could do. When they had the conversation how they could simplify their analytics framework, improve operational intelligence, they said this is like, it's the end-all be-all. And their Splunk folks are very confident and love their solution as they should. And they have a tagline that says, if you're not using Splunk, you're doing IT wrong. Which is, it's kind of bold, but I think when you play with it, it is really powerful. And so we helped that customer who wanted to deploy that 4 terabyte license very, very rapidly. We built them a VBlock, and from the time they signed the purchase order, within 45 days, we had the application installed and already in their data center. So very, very rapid. Now, if you want to talk to EMC about Splunk, we have ninjas. Now, you may or may not be aware of this. A Splunk expert is referred to as a ninja. They even have a Ninja Academy. You get your ninja status by accruing basically a certain number of accreditations and then participating in their very vibrant online community. They've got a great kind of community network. Feels very open sourcey in terms of the way people interact. But anyways, so if you want to talk to some ninjas, folks at EMC that really understand Splunk, that have been through the same training that Splunk SEs have been through, and have a global view of what other Splunk customers are doing at scale, then give us a shot. I run the Ninja team. We've got about 30 people globally that are focused on Splunk, and it's really exciting. We also run some teams that are focused on Hadoop, so if Hadoop and big data and analytics are interesting to you, I highly encourage you to reach out to EMC, and if you don't want to take a sales guy along, I get it. We got great pre-sales engineers. They'll come out and give you the technical truths. No picking on salespeople. If there's any in the room, you do a great job. Anyways, if you want to hear with some tech geeks that can peel the covers back and tell you how this stuff works, we'd certainly welcome that. Anyways, that's what I wanted to share for you here today. Hopefully we've kept it concise and on time. If you have any questions, I'll take a question now if you want.